about a paper we published earlier this year on the likely environmental sustainability impacts of special housing areas in Auckland, and just briefly acknowledge our co-authors, Rafe, also Philippa Howden-Chapman, our boss, and Jonathan Moores of NIWA, who did a lot of the work that we're going to present today on stormwater contamination. And we'll also acknowledge the funding from IMBI, which funded not only this research, but the whole of the Resilient Urban Futures program, which Rafe has covered in a bit of detail there. Cool. So special housing areas, I'm pretty sure most people interested in this area will have heard the term. Essentially, they are created under the SHA legislation. They allow pieces of land to be designated special housing areas, and qualifying developments within those special housing areas can essentially have a streamlined resource consent process that does not necessarily go through the RMA if developers choose that. There are also, pretty relevant from our perspective, the possibility of getting the basically the proposed Auckland Unitary Plan rules will apply. So since we're very interested in compact versus dispersed development, the key thing in the proposed Auckland Unitary Plan is the expansion of the old metropolitan urban limits to the new rural-urban boundary. So that was one of the things that first interested us, was the possibility that Auckland was going to get bigger, and I'm sure Larry is going to talk about a lot more of these things in greater depth. So I'm going to go straight on to basically the work that we did. So we were particularly interested in looking at the environmental impacts of SHAs. We wanted to take advantage of administrative data and tools that were relatively easily available, because we kind of were aware that this was a really important policy tool. There was a lot of talk about it, and we wanted to see what we could do from the outside, taking advantage of the skills that we had. So we were particularly aided by the fact that Auckland Council makes available predictions of, actually they've got a lot of really great data on their website. They predicted how many additional dwellings each of the SHAs were likely to produce, and that was the basis of a lot of the work that we did. So we took that information, we took 2013 census data, we took some work by NIWA and a model that they developed with Auckland Council, and we focused in on the areas of population weighted density, climate change, which Rafe has talked about already, and stormwater contamination. And I'm going to pass you over to Ed now, who will be talking about the first of these.
Thanks, Nick. So as Nick said, we wanted to include a measure of density, basically as a measure of the compactness of a city. And it's reasonably well established that compact cities are more sustainable, more livable, and have a smaller environmental footprint. So the measure that we chose was population weighted density. So this is a measure of the density that is experienced by the average person in a city. And we calculated this we calculated the combined and individual impact of each SHA on Auckland's population weighted density, and comparing the baselines of 2013 density with adjusted densities for each SHA and all the SHAs together. So quickly go through some results. At this point I should point out this was done a few months ago when only the first 3 tranches of SHAs had been announced, so we're looking at about 80 areas at this point. So if all of the dwellings in the qualifying developments in these first 80 SHAs had been created or will be created, we'll get a pretty modest increase in Auckland's population weighted density of around 4%. And while that's not detrimental to Auckland's density overall, Auckland Council has a clear goal of becoming a compact city that's set out in their Auckland plan, and that sort of 4% increase isn't making sort of great strides towards that goal. So if we look at the SHAs individually, you can see that their impact varies quite substantially. And if you look at this bottom box down here, you can see that those SHAs, can't really see, but you'll have to trust me that those SHAs closer to the central city tend to increase Auckland's population weighted density. There are a lot of SHAs in here that don't really show up. While those that are further away, especially down in the southeast and up in the northwest of Auckland, tend to decrease the density. So there's clearly room for improvement in achieving that compact city development. So I'll now just hand back to Nick to talk about commuter patterns.
Cool. Thank you, Ed. Cool. So yeah, Rafe has talked about the importance of climate change and its significant place in both central government and Auckland Council goals. Naturally enough, where we build houses is going to dictate how long people's commutes are and what commuting choices are available to them. So we basically took advantage of some work by a couple of researchers called Mattingly and Morrissey to try and use 2013 census data as a way to predict the likely impact, or rather likely commuting patterns of future SHA occupants. So basically, Statistics New Zealand divides New Zealand into census area units of about 3,000 to 5,000 people. They get questions about where people work and also how they went to work on the day of the census. So what we did is we obtained basically all of the data that they could share with us on trips between census area units on the day of the census, and Ed used his GIS expertise to calculate the distance on Auckland's road network between all the different CAUs, and then by making some assumptions about emissions factors for cars, buses, trains and the like, we were able to kind of come up with a sense of what the average commuter was like in each of Auckland CAUs, and then finally we made a reasonable assumption that the occupants of the new SHAs were likely to have similar commuting patterns to the nearest census area unit. So this was how we went about making our predictions. And cool. So we found that overall the average commuter emissions of CO2 were about 22 kilograms less per year than the Auckland average. This is assuming that all of the predicted dwellings take place. And if I can get this going up here. What you can see, maybe unsurprisingly, is a lot of blue and yellow in the central city, closer to employment. Of course, acknowledging that Auckland is a multi-nodal city, certainly there is more employment in the centre. And then as we get up to the far north, and again this cluster here in the south, we have some more problematic locations of SHAs in terms of commute emissions. Right. Turning to active commuting, you'll see a lot of red here. Basically, the average proportion of active commuters in the SHAs was but 4.3% versus 6.6% across Auckland as a whole. And the reason is really that there is a pretty well-known upper limit in how far people are willing to cycle to work. I think about 7 kilometres is often thrown around, and so if you have this circle here, that's about 6 kilometres around Queen Street, and within we have a lot of blues and yellows, but everywhere else a lot of reds. And it's possible that this is unavoidable given the conflicting goals facing Auckland Council, but it's certainly interesting to note from our perspective as people interested in climate change and also public health, because of the many public health benefits associated with active transport. Right, so I'm now going to pass you back to Ed, who's going to talk about the final area that we looked at, which is stormwater contamination.
Well, thank you. So we wanted to include a more of a direct measure of environmental footprint in our study. So we turned to one of our colleagues at NIWA, Dr. Jonathan Moores, who's been working with Auckland Council to create a contaminant load model, which is basically a model to assess the amount of contamination getting into the stormwater system in the Auckland area. So he started off by using aerial photography to categorise each SHA, firstly by development type, whether they're greenfield, brownfield or infill, and then by dwelling density. And he then used this along with the developable areas that were published by the council to estimate land cover that was divided into roofs, roads, pavements and vegetated surfaces. So with all this information, he was able to estimate annual stormwater contamination from the average new dwelling in each SHA. And for this we focused on zinc and copper loads, not only because these are particularly damaging to estuarine and coastal ecosystems, but they're also indicators of wider ecosystem health and are of particular interest to Auckland Council at the moment. So we'll quickly go through these results as well. Don't worry too much about the detail on these graphs. Basically we've got the SHAs listed along the bottom, and they are grouped by development type, the 3 types there. And within those groups they're ordered by dwelling density. So on the left we've got the most dense, and on the right we've got the least dense. And then up the side we've got the change in annual contaminant load. And so this is for copper, this is for zinc, and the important thing to notice is that basically the patterns are very similar for the two. So we'll go through with just one graph up, just to illustrate. So basically we expect to see an increase in copper and zinc in most of the SHAs. And on a per dwelling basis, the load increases as the dwelling density declines. So as you move down these groups, you get more load, and that's basically because lower densities mean more impervious surfaces, so therefore more stormwater runoff and more contamination. Loads, especially zinc, tend to decline in brownfield development, this group just here, and that's basically because old materials, particularly zinc and lead piping, are being replaced by newer, less polluting materials. And there is an important thing to note with these results. The SHAs had to abide by proposed Auckland Unitary Plan rules, and those rules require greater stormwater treatments for developments. So these results aren't a prediction of the actual amount of pollution that will reach the water bodies, but they do indicate some clear opportunities to save costs in terms of water treatment if we sort of address some of these more polluting SHAs out there. So I'll just hand back to Nick for some conclusions.
Thank you, Ed. Cool. Yeah, so really to conclude, we found that there was a pretty limited benefit for Auckland in terms of reduced carbon dioxide emissions and increased density, which, as Rafe kind of noted, is not consistent with some of the long-term goals of Auckland City, but naturally enough reflects a balancing process and the underlying challenges that they face regarding housing supply. But yeah, in short, from our perspective, a little bit concerning. We also note a slight reduction in active mode use due to the location of SHAs. Ed's pretty beautifully summarised the greenfield development work. Basically, greenfield developments are going to have a larger impact on stormwater contamination or mitigation costs than either infill or brownfield. And overall, yeah, we have concluded, as I say, that SHAs make a weak contribution towards making Auckland more compatible or sustainable. Just briefly to talk about future research before I pass over to Professor Murphy. We are currently taking the data Auckland Council provides on the remaining 7 tranches of SHAs and carrying out our analyses again to see if any new and interesting patterns emerge. We're also working with NIWA to take advantage of the TOTUS model to hopefully make some predictions about the impact of special housing areas on Auckland's air quality and also traffic bottlenecks and traffic flows. And there's finally the potential to apply these tools to the SHA projects of other New Zealand cities, although we certainly need to get our hands on some key data regarding predicted additional dwellings if we're going to do that. Cool, thank you very much. We'll pass over to Professor Murphy.